Good day, everyone. I welcome you back to Global Education Zone, the home of impactful learning. It's nice over here for you and I because learning never ends and education is the key to an impactful life. Everyone, my name is Anthony Nathaniel, and I welcome you once again to Global Education Zone channel. And in this particular episode of this video, we are going to be talking about sequences and series. Now, what is a sequence and what is a series? A sequence is a set of terms arranged according to a rule. Now, a sequence, for example, could be a rule that says that every number, every term of that sequence, to get the subsequent term, you have to add a constant. So for example, if you have to add subsequent of 2 to a constant, to each term of the sequence. If your first term is 5 and you keep adding 2, so you end up getting 7 at the next, and then you end up getting 9, you end up getting 11, and so on and so forth. So this is a sequence of a difference of 2, and any sequence that has a difference is known as an arithmetic progression. So now, these arithmetic progressions, they have their general formulas. An arithmetic progression is simply represented as, when you are looking for the nth term of an arithmetic progression, you represent it as Tn equals a plus open bracket n minus 1 times d. So this is actually a not very difficult concept to grab. It's a general formula for an arithmetic progression. When you are looking for the nth term of an arithmetic progression, it's equals to the first term plus the n minus 1 times the difference. The difference is that common number that is added to subsequent values of that progression. For example, in this first one I've listed here, we have 5, 7, 9, 11. You can see that when you have the first value, you add 2 to it to get 7, and then when you have the second value, you still add 2 to get 9, and when you have the 9, you still add 2 to get 11. So when you keep adding 2 and 2 and 2 and 2 and so on, that 2 becomes your common difference, and that is represented by d in this equation. Then your a is represented by the first term in your arithmetic progression, that is 5, and then your n is the nth term. So your n is the number of terms, the number of the term you are looking for. For example, if we are looking for the 5th term here in this equation, assuming there's a dash here. This is often common in basic arithmetic questions for primary school and junior school. So if you put something like this, you're asking to look for the next value of that sequence. All you need to do is you make use of this formula. So you say that and we're looking for the 5th term. So that 5th term, we're looking for the nth term, where n is equal to 5. That means the 5th term, which is T5, equals the first term is 5 plus open bracket n minus 1 is 5 minus 1 times the common difference here is we keep adding 2. So that would be 2. That would be 5 plus 5 minus 1 is 4 times 2. That's 5 plus 4 times 2, that's 8. 5 plus 8, that's 13. So our next term will be 13. So we'll write 13. So, and if you don't know how to look for the difference is basically gotten by Tn minus Tn minus 1. So for example, when you just simply subtract subsequent term, you get the common difference. For example, this 11 minus 9 will give you a common difference of 2. 9 minus 7 will give you a common difference of 2. 7 minus 5 will give you a common difference of 2. So what I mean is, when you keep subtracting subsequent values, you will get your common difference. Now, this is for arithmetic progression, and this is the basics stuff for arithmetic progression. Now, before I leave arithmetic progression, let's talk about how do we get the sum of n terms of an arithmetic progression. Now, without giving you the derivation, the sum of n terms, Sn equals n over 2, open bracket, 2a plus n minus 1 multiplied by the common difference. So it simply equals to n over 2 open bracket 2a plus open bracket n minus 1 close bracket d close bracket. So what is, and your n is still the nth term, your a is the first term, and then your d is your common difference. So these are the two formulas you'll be making use of. So the first formula you're making use of is this formula 1, next second is formula 2. So now, after talking about arithmetic progression, let's talk about geometric progression. Now, in your arithmetic progression, I stated that you keep adding a common difference, right? Now, but this time around, in a geometric progression, we will keep multiplying by a common ratio. So that means if you have a first term of a, your next term will be a multiplied by the common ratio, that's ar. Then your third term will be the second term multiplied by the common ratio, that will be ar squared. Then your fourth will be your third term multiplied by the common ratio, that's AR cube, and so on and so forth. So when you divide a term by the term before it, you get the value of the common ratio, and that is simply how geometric progression works. Then if you are looking for the nth term of a geometric progression, Tn will be equal to what? We are looking for the nth term of this progression. So this nth term is given by an equation that represents that nth term in terms of the first term, and that's it here. A r raised power n minus 1. That's the general formula, because Tn is equal to A times r raised power n minus 1. Your A is the first term, your r is your common ratio, and your n is the nth term you are looking for. For example, if you have a geometric progression of 6, let's call this 9. So we are looking for the third term of this geometric progression. So T3 will be equal to what? A r raised power n minus 1. Your A is what? Your A is 6 times your r. Your common ratio is basically your term minus the term before it. So that of 9 over 6. So you raise this 9 over 6 to the power of n minus 1. Our n here is what? That's third term. So n is 3. So 3 minus 1 is 2. So 6 times 9 over 6 raised power of 2. That's 6 times 9 over 6 is equivalent to 3 over 2. 6 times 3 over 2 squared. That will be 6 times 9 over 4. That would be equal to 9 times 3 over 2. That's 18. Right? Rather, that's 27. All over 2. So that will be our third term of this geometric progression. So lastly, let's talk about the sum of terms in a geometric progression. So the sum of them equals what? A open bracket r raised power of n minus 1 divided by r minus 1. So this is the general formula for looking for the sum of terms in the geometric progression. And then the sum of infinity is given by s equals a over 1 minus r. So sum of infinity is simply the sum till the infinity of a geometric progression. So in summary, we've talked about the nth term of an arithmetic progression, which is a linear progression, is given by a plus n open bracket n minus 1 close bracket d. The sum of terms up to n of an arithmetic progression is given by n over 2 open bracket 2a plus open bracket n minus 1 close bracket d close bracket. Then for a geometric progression, we have the nth term is given by a r raised power n minus 1, where n is the number of the term you are looking for. Now, then lastly, we talk about the sum of terms is given by a open bracket r raised power n minus 1 close bracket divided by open bracket r minus 1. So and then the sum to infinity of a geometric progression is given by a over 1 minus r. So hopefully, if you enjoyed this video, and in subsequent video of revision, I'll be performing calculations on these equations and these concepts. Thank you for watching, and see you next episode.